Black math! Give me some math and I'll give you some flack. Black math!
Okay, here we go. We're going to talk about quadrilaterals, whether they're parallelograms or not. Okay, so what's the definition of a parallelogram?
Something that is parallel.
Like opposite sides parallel.
Yeah, opposite sides are parallel. That's it. So we're going to determine whether quads are parallelograms. Okay. So there's some properties other than the definition. Definition says if it's a quadrilateral with opposite sides are parallel. Okay. That's the definition. But we can also decide if it's a parallelogram by doing this. So identifying parallelograms. If both pairs of opposite sides of quad are congruent, then it's a parallelogram. Okay, so not only the definition says they have to be parallel, but here's a property that says if both pairs are congruent, then it's a parallelogram. Okay. So let's see here. We're going to prove with algebra.
What class is this?
Sorry, they just kind of tuned out. I said the A word again. Okay. So we're going to determine whether this is a parallelogram. Okay, so let's see here. Let's say this is 6x degrees. Oh, we also have this. If both pairs of opposite angles are congruent, then it's also a parallelogram. Okay, so let's say this angle is 6x, this is 3x, and then this is 5x minus 40. 5x minus 40 degrees, and then this is 5x plus 20 degrees. Okay, we're going to determine whether these are, this is a parallelogram. Let's say this is 3x plus 2 and 5x minus 38. Okay, so here's the deal. The only thing that we're given is that the top and the bottom are congruent. So if that's the case, then we can set these equal to each other. The only thing that we're given are these two hash marks here. So it's not enough to have one pair of opposite sides congruent. Otherwise, we could say, yes, they're congruent. Yeah. Well, let's see. Well, since these are the same, we're going to set them equal to each other. 3x plus 2 equals 5x minus 38. Okay, how do I solve for x? Let's see. Let's get rid of the x's on this side and the 38 on this side. So then you get 2x equals 40. I think that concussion might have knocked something, not loose, but like it might have attached something.
Here's the thing. If you look at it, it's pretty easy because if you can pretty much like say that they're congruent, key and pawn, like the angles are because they're opposite sides of a parallelogram.
Yeah, so that we want to prove that. Yeah, so that's what we're trying to prove. So now, if we plug in 20 and then we get the same thing, then we did, and that's what Tori just did. 6 times 20 is 120. 5 times 20 is 100, plus 20 is 120. These are congruent. Now we just have to prove that these are congruent. 3 times 20 is 60. 5 times 20 is 70. 100 minus 40 is 60. So those opposite angles are congruent too. Okay, so yes, this is a parallelogram. All right, here's another one. So here's property 1, property 2, here's property 3. If one pair of opposite sides of a quad are parallel and congruent, then it's parallelogram. If one pair, not both, one pair of opposite sides is both parallel and congruent, then it's a parallelogram. Okay, so if you just prove that one pair of opposite sides is congruent, that's not enough. But if you prove that two pairs are congruent, that's enough by principle 1. The principle 3 says if you just have one pair to work with, but you can prove that they're both congruent and parallel, then you got yourself a parallelogram. Okay? That's principle 3. Okay, I'm going to skip example 3, move on to the next principle. Here's the next principle. Number 4. If the diagonals of a quadrilateral bisect each other, then it's a parallelogram. If diagonals bisect each other, then it's a parallelogram. So for example, here's what the proposed parallelogram is. So a diagonal looks like this. Another diagonal looks like this. So if these bisect each other, so if they separate it into two congruent segments, then it's a parallelogram. Okay? So the diagonal one is a little weird because it's just, when you think of parallelograms, you don't automatically think about their diagonals. You think about the sides that are either congruent or parallel or whatever. But this is a principle that we have to consider. So that means if you have the converse is true for all these. So if you have parallelogram, you can say that these two have to be the same and these two have to be the same. Now the diagonals are not the same length. If they were, this would be a rectangle. But see how this red line is a little shorter because it doesn't have as much to travel as the blue line. It goes from far end to far end. Okay, so this guy, but we do know that these have to be the same length and these have to be the same length, but they're not all the same length. Okay. All right. Let's move on to lesson 62. Okay, lesson 62 is so pre-algebra, but the geometry part of pre-algebra, which is surface area.
I haven't taken pre-algebra since seventh grade.
Yeah, well, we did some of it in our algebra classes as well, but
I did it in seventh
Yeah,
grade,
I
and
took it in
that's
8th
senior.
grade. No, I didn't take pre-algebra.
yeah, well, Math 8.7 has elements of pre-algebra in it, and you just skipped right to algebra.
I just didn't.
Usually you need your math teacher's approval to do that.
I'm sorry.
So we're going to find surface area and volume of cylinders.
I don't remember anything from pre-algebra. I haven't taken pre-algebra since I was like,
Okay, remember cylinders, circles have their own snobby language. Okay, cylinders are like the circular version of a prism. Okay, so it's the same shape all the way up, which means you could find the volume the same way. The volume is still,
isn't it the base of the prism?
yep, the area of the base of the polygon or the prism times the height. But basically a cylinder is the circle's version of a polygon, of a prism, because it's the same shape all the way up. So if you find the area of the base, multiply by height, you're good. Area of base is always the same in a cylinder. What shape is the base? How do you find the area of a circle? All right, pi r squared, and then you just need to multiply by the height. So the volume of any cylinder is pi r squared h.
Give me some numbers.
All right, I'm going to give you some numbers, and you can do this in 5 seconds. Ready? Find the volume of this cylinder. Okay, maybe 10 seconds.
The volume?
Find the volume.
Okay, I
In the
2,000 pi. Yeah,
No.
that's what she said. Not what she said. No, just kidding. I know it's
Are we doing it in forms of
Please let me.
Oh, you
I
can
got this.
you can leave it. Oh, did you say 2,000 pi?
Yeah.
Yeah, you're right. Sorry, I thought you meant
Yeah.
2,000. Or 2,000 pi. If you wanted to do in terms of 3.14 ish, then what would that be? 6,280. Okay. But right, 2,000 pi. Tori, nice work. And Jilly, because you agreed with
I
it.
did.
I also agree with it. No.
Okay. Good. All right, that's volume, but surface area, what is that? That's the top, the area of the top, plus the area of the bottom, plus the lateral area. How do you find the lateral area of a prism? You guys remember the shortcut?
You just make it into a rectangle. Right?
Yeah, you make a rectangle, so how long is that length?
diameter plus height?
Not diameter times 8, you said?
I said height.
Nope, not quite. What's that length there? What's that called?
It'd be the height, because it's just
Well, this is the height. Yeah, so this is the height. But what's that length called?
base.
It's not the base. The base is a circle. But what is that? Think about a can of soup and you just unwrap the label. What is that length?
Width?
Not width. Not like
Length.
20 inches, right? That's the width of that. It would be 20 inches, but it's not. What is that? You just unwrapped it. What is that length?
Is it the diameter?
Nope. Okay, so let's unwrap it. Here's my cylinder. I unwrap it. What is that length there?
The height. The weight base.
Oh wait, no, it's the
Circumference.
Circumference. Yes. So how do you find the circumference?
Oh, I know that's diameter pi, right?
Yep, diameter times pi. So this is pi r squared plus another pi r squared plus pi dh. Diameter times pi. And then the area, remember, is length, which is diameter times pi, times the height. So pi dh. So pi r squared plus pi r squared plus pi dh. Remember, in a prism, like if I had a so that's still, the surface area is still top plus bottom plus that rectangle. Remember, circles are snobby, so they have their own definition, own word for the distance around, but this is just pH, perimeter times height. That's what that is. So if you unwrap this label, it's still a big rectangle. And that length is the distance around the rectangle, or that pentagon on the bottom. So that's the perimeter. Okay? So that's pretty easy. You just really need to know those two things. Finding the volume and surface area of a cylinder. So let's do some examples and see if this is sinking in. So I just want to find the lateral area, find L of, it just says L, that's weird, of this. So just find the lateral area of that cylinder. You can give me in terms of pi if you want.
Yeah.
Just the lateral area. How do you find the lateral area?
I don't want to put these all together, but is it 16 pi plus 16 pi plus 72 pi?
So that's if you're finding the whole surface area. So you're just asking, I just want to know the lateral area, which is the stuff, the label on the side. What is it?
So it's 72 pi.
72 pi. Do you see how she got that? It's just pi dh. What's D?
I have a question.
Yes,
What is that top number right there?
4 feet.
Oh, see, I thought that was 9.
Or did you think that when I said it was 4 feet? Or did you just ignore me and then try to look for yourself? Maybe you should have taken pre-algebra. All right, so pi dh, if that's 4, then d is 8, right? Because this is just the radius. So the diameter is all the way across, so that's 8. H is 9. So 8 times 9 is 72. So pi dh would be 72 pi. Right? That's all I did. So 72 pi. So L always equals pi dh. So pi times 8 times 9, which is 72 pi square feet. Okay, so if I did want to find the surface area, then I would do what Tori said. I still need the top and pi, so top and bottom. So you need a 16 pi, which is pi r squared. That's another 16 pi. Yeah, so you got, what is that, 104 pi square feet. Okay, does that feel all right? You guys remember doing this in pre-algebra?
No.
Tristan doesn't. Makes sense. Okay, that's it, guys. That's it. What a good day. All right, so here's the deal. We've got 43, count them, 43 minutes. You can get some Flack attack coupons. I've got a special deal for the day. For every 5 problems you do, and I can put stuff up here. You can also use a device to do your homework as well. If you do that, for every 5 problems you complete, I'm going to give you a Flack attack. So if you do 25 problems today, which is possible, then you get a free problem set because you get 5 Flack attacks, and every 5 is a free problem set, right? Okay. You can also work on your test if you want. If you haven't finished that yet, you also have homework that's due tonight. You have 60 that's due tonight, and your pre-test and your test that are due tonight. Okay.